Dr. Abraham Flaxman. Aby is an associate professor in global health and health metrics at the University of Washington. He leads the development of new methods for cost-effective analysis with microsimulations and is engaged in operational research and verbal autopsy. So please join me in welcoming Aby as he discusses his work, related work to Tyler's on thinking about verbal autopsy, but for a very vulnerable population.
Thank you, Josh, and thanks everyone. Have you ever heard of verbal autopsies before? This talk is kind of like a prequel to Tyler's talk. I'll begin just by acknowledging that this research was conducted on the traditional lands of the Coast Salish people, and also showing this disclosure of my grant and research support. If I hadn't had the tee up that we just had from the previous talk, I'd do about half of this time just trying to convince you that verbal autopsies are an important thing. And so I'll kind of breeze through that stuff, but talking about sustainable development goals and how cause of death prediction can help us meet them, and how verbal autopsies can help us understand what the causes of death are in different places. And then what I really want to do is go back to this kind of using these breakthrough new generative AI techniques to do this kind of cause of death prediction from verbal autopsy interviews, which, just because it's on top of mind, I'll be testing with that same sort of PHMRC gold standard validation data that you just heard about. And you saw maybe a little sliver in Tyler's pots of how much of that data was about maternal mortality specifically. That's what I'll be keying in on, but let's tee it up a little bit first. Perhaps some of you saw or worked on the goalkeeper reports that came out recently, showing where we are in terms of some key sustainable development goals and how far we have to go from where we are now if we hope to meet those goals in 2030. For example, that middle plot about under 5 mortality shows that we've come a long way since 1990. Progress has stalled out a little bit in recent years. And even in our most optimistic projection of where we're headed, we're going to be close, but not quite at our 25 per 1,000 goal when we hit the deadline of 2030. But these sorts of global pictures hide substantial heterogeneity. And so the same colleagues of mine, did I say that I'm from the University of Washington Institute for Health Metrics and Evaluation? So I have a very like IHME centric approach to these kinds of health statistics. My colleagues who worked very hard to make projections that kind of like got rolled up into some of the figures on the last slide also have a way to do this country by country and draw by draw. And so when they say, you know, we're not on track to meet our global targets, well, the Philippines maybe met their target. Maybe in 2019 they had crossed that boundary, but there's a lot of uncertainty about that. But as things go on, it seems quite likely if they continue as they've been going, in 2030 they're going to hit their goal. And that is not true for everywhere. So this little animated slide that made my slide deck too big to email to the excellent tech team flips through how a lot of different places have a lot of different trajectories if things continue as they've been. And so this is the kind of consideration that brings me to saying, let's talk about cause of death prediction. Because if we understand what the specific causes are that are behind those targets that we're trying to reach and behind those curves we're trying to bend, that can really help us in terms of figuring out where we want to make changes. And the Global Burden of Disease study is one effort to do that. Here's a very cool sort of 3D picture of the way the Global Burden of Disease study breaks down cause of death. The third dimension doesn't really add anything here technically. It's just for like graphical design purposes. But it looks awesome, right?
Hi, Aby. Just so you know, the slides aren't showing. So if you could maybe describe what's on the slide for the audience, we appreciate it.
For those of you who can't see the slide, it is a 3-dimensional rendering of a tree map, which even in 2D is sort of a glorified pie chart. And I'm going to advance it when my clicker starts working again, to show you that, oh, looks like you're going to be able to see this one before I have a chance to advance it. On the IHME website, you can find an interactive version of this that's not 3D, that's not as cool looking, but that is regularly updated and gives you a way to drill down to look at this sort of heterogeneity that I was talking about earlier. It was once described as something that is takes a while to get good at finding your way around, but once you figure it out, can be very informative. And what I'm going for with this is really that if you were to look at, for example, South Sudan and think about what you might do to bend the curve there, you might look into this big wedge that says diarrhea, this big wedge that says malaria. Those are some of the things that jump out to my eye when I'm looking at it, compared to Fiji, which was another one of those countries where maybe they'll meet the goal, but we really hope to bend the curve from where it's been going historically, where STI jumps out at me as a big one. And that's probably congenital syphilis, which, is something that we've got a lot of good ideas about what to do about, but is not something that would be as important if you're trying to bend the curve in South Sudan. And the problem when you start looking at all of these beautiful tree maps, whether they're rendered in 3D or an interactive version in 2D, is where does the evidence base come from to fill in these maps? Well, the best place to get it from is vital registration systems, stacks and stacks of death certificates that say what was the underlying cause of a death. And unfortunately, many of the places that we were looking at on the animated slide showing all of the different countries where we hope we can bend the curve to go for our SDGs are places where there is not vital registration data available. All of the ones shown in gray on this map that my colleagues from the cause of death team at IHME regularly update. And that brings us to the prequel to Tyler's talk about verbal autopsy, because I believe that verbal autopsy interviews are one of the best ways to fill the gaps when we don't have death certificates because we don't have a vital registration system. In short, a verbal autopsy means go ask. You find someone who's familiar with the illness that led to the death, and you sit them down for an interview, and that interview might take 20 to 40 minutes. And afterwards, you have someone who's familiar with the kinds of illnesses that happen in the place where the interview was conducted, read all of the questions, read all of the answers, and try to figure out what was the underlying cause of death. And I'm going a little bit quickly because you did hear about this all in the previous talk. But it was actually pretty cool when there was like a voice from above with a technical question about the slides. So if there are questions as I go, I could probably field some. The kinds of verbal autopsy questions that you might see are shown on this slide. It's sometimes called a semi-structured interview because they're questions like, did blank have fever during her last illness? If so, how many days and months before the death did the fever start and end? But it also has these open questions like the ones Taylor focused on that say, just tell me in your own words what happened. And that's sometimes called the verbatim section in a verbal autopsy interview. And what I am super excited about is the prospect of these AI algorithms to do more with the verbatim section than we've ever been able to do before. Is this an audience that's like super familiar with VA? If you are, I could skip through this, but if you haven't seen it before and I saw a few heads shake, this is the kind of task for going from verbal autopsy interview data to figuring out what the underlying cause of death was. And for those of you who are clinically minded, you can try this task right now. The deceased was a 35-year-old male that had a history of asthma and heart disease and hypertension. During the final illness, they had ankle swelling, puffiness, cough, difficulty breathing, more than usual protruding belly, and they had these risk factors. And then in that verbatim section, before we had all of these amazing new tools, we used to do this kind of like very simple word extraction. And you just say the free text included words like asthma, breath, heart, lung, swell, and water. And so, people who have like gone to med school a little bit and sat in this talk say, oh, that sounds like heart failure. We learned about heart failure. But in the global burden of disease taxonomy, we always think of heart failure as an intermediate cause. There's always something underlying that heart failure. And from the design of the PHMRC data collection study, we actually know in this case that the underlying cause was COPD. So I saw some nods with people maybe who have this kind of clinical idea, thinking like, okay, that seems basically consistent. But that gives you an idea of the kind of prediction challenge underlying this kind of verbal autopsy-based cause of death prediction. And I'm going to talk about AI in a sec, but I think as I get so into the numbers, it's important to remember that, like, as Tyler mentioned, a lot of these interviews are really asking people about like one of the worst days in their lives. And so just like respect, the kinds of things that we hear are like this one. Our baby girl was born in a hospital. After 2 months, she started to have coughing problems and a fever. We took her to the hospital. The doctor said things were serious, sent us to another hospital. She was given oxygen and glucose. Doctors couldn't be certain she would survive. She had fits. She lost consciousness, and she died. So serious, deep stuff. And if there's a chance these new breakthroughs in generative AI and cause of death prediction can help us use this interview data to improve cause of death prediction, to bend these curves, to avoid these unnecessary deaths, like we got to do that. So getting into generative AI for cause of death prediction for verbal autopsy interviews. When I say generative AI, I mean something pretty specific. And I mean these new artificial intelligence techniques that create or generate new content. ChatGPT, Claude, Gemini, these are the text-based ones. These are the ones that I'm going to be trying to use in this talk because I've got text-based data. But generative AI also includes things that create images like Stable Diffusion or videos like Sora. And lifting the curtain a little bit, chatbots are not magic. They're statistical language models. And so I think we're not too far off if we think of them as probability distributions over words. They're a very complicated way to say, if you've seen words W1, W2, ... then the probability that the next word is WN is this. And for each next word, it gives you a different probability. And it just does it so well that like you can stay up at night saying, am I just next word prediction? It's like amazing what a statistical language model that's just doing next word prediction is able to do. And so we actually saw on Tyler's side the sort of prompting that's gone into this. Here's the prompt that I've been using to ask ChatGPT to act as an automated verbal autopsy algorithm. I bolded things just to kind of call them out for your attention, but the things I wrote in all caps, like I'm yelling at it, actually are in all caps in my prompt. And one of the best practices that's emerging for doing this kind of prompting is that kind of tell the AI what role you want it to fill. Another one that's been pretty interesting and that I was able to test in this context is called chain of thought reasoning. And so when I say, think it through, that's an idea that I've tested with and without to see if it's better able to predict the underlying cause of death using this chain of thought reasoning. I won't leave you hanging. It's better. And so this is the kind of prompt I have, except the interview transcript, which is going to come from the real data collected in that semi-structured interview from the verbal autopsy. And what that interview transcript looks like, I formatted it as a question and answer, where the questions are the sort of English version of the thing that was asked, and the answer is English representation of the semi-structured data. Sometimes that might be a yes or a categorical answer like male, and other times it's going to be that verbatim text that writes out in detail what happened during the final illness. You can see that this data is redacted, it's openly available, and so I think on one of the slides we talked about like intellectual property and kind of privacy and confidentiality. In this kind of test, we didn't have to worry about that. And because we're doing this chain of thought reasoning, AI response starts like this, and I couldn't fit it all on one slide, but this gives you a kind of flavor for the way this blah, 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 just next word prediction puts together something that for those of you who are clinically minded in the audience, you'll see seems like a pretty coherent answer based on, well, I haven't shown you everything that went in, but the kinds of stuff that you see in that verbatim question. And so then the final step in this kind of chain of thought reasoning is to follow up with a question that says, now, I would really like to know what the underlying maternal subcause is from this list of possibilities. And you can yell at it a little bit, like, please respond with only the letter of the correct option. Doesn't always work. It's just saying things randomly, like it's seen people say, and you've been on the internet, you know people don't always answer as they're instructed. But in this case, the AI response was the single letter C, which if you have that kind of clinical mindset, and we're reading quickly on the last slide, you'll say, you know, that seems pretty reasonable. From the things that are presented here, sepsis is probably the best answer. It kind of sounded like an unsafe abortion. So if there was a way to go like to the underlying cause of the underlying cause, maybe we would have said it was abortion. And so then maybe there's a question mark like, well, should we have just gone for that from that F, other defined causes of death as a consequence of pregnancy? But we know from the validation data that according to the criteria from the PHMRC study, C is a correct answer in this case. And so that gives me a way to test how well this works. And the quality metric that I'm really keying in on comes from my interest in using this for those kinds of global burden of disease estimates. We call it the CSMF accuracy. And what it is effectively is to look at the difference between the true and predicted percent of deaths by each cause and take the sort of absolute sum of those differences and then scale it so that it's between 0 and 1, 0 being as wrong as you can possibly be, and 1.0 or 100% being perfect prediction at the population level. And when we're making these predictions, and this came up earlier, good question, Roy. Did he leave already? It's absolutely essential that we do out of sample validation. So there's a pretty complicated approach to this that we've come up with, because if we aren't careful, then we might end up with, although we've got totally different data in the test data pool and the trained data set, they'll have the same fraction of causes, just because sampling without replacement in a 25-75% split is likely to come up with the same breakdown of causes. But when we're dealing with these AI models that were trained on who knows what, there's even more things that we have to worry about, because like I told you that these data have been redacted and have been published. Well, it is always great when someone reads my paper, and if the AI read those papers, like, then haven't they seen some of this data before? But the good thing in this case is that we are so bad at predicting these pregnancy-related subcauses that we never published those. We just said it was a maternal death. We never said we thought it was sepsis or we thought it was preeclampsia. So for this one, I know that this really is out of sample data that I'm validating. And without further ado, here's how it worked. We have from the PHMRC study the ability of human doctors to do this prediction. CCC is sort of an individual level prediction. It's a concordance, but corrected for chance. But as I said, I'm keyed in on the CSMF accuracy, the one that tells us how we're doing at the population level. And the takeaway is these AIs can beat the level of human experts in individual and population level quality for predicting pregnancy-related causes of death. It's getting good enough to the point that, like, I think we can use this information. It's pretty interesting to see that both with ChatGPT and with Claude.ai, the chain of thought really helps. And I was also interested to see that Claude.ai was the winner in this competition that I ran. Now, all of these models are always changing, so I really have to do it again. This is with ChatGPT 4, before they did 4.0, before they advanced that to 4.01 preview, or whatever their excellent name for it is now. So I'm very interested to go back and see if the latest and greatest from OpenAI can go even beyond that 63 CSMF accuracy. But each one of those increases in the percentage points for CSMF accuracy is kind of like a hard-fought battle. So just seeing it go from 50 to 63, I'm amazed. I am pretty impressed by what these things can do. And I've got to wrap up now, but I'm going to wrap up by saying this has actually been used. And there's this dynamic group called Make Deaths Count. They're sort of Yale med students who got really interested in conducting VAs. They've teamed up with the Somalia Institute for Health Research and piloted a collection of 50 VAs where they know or are pretty sure it was a maternal death in Somalia. And part of the way I got started really keying in on this subcauses of pregnancy-related deaths was that they had this data in hand. And we're saying, the tools that are out there seem to only say that it's a pregnancy-related death, which we kind of already knew. That's why we collected the VA. Is there more we can do? And it works. I mean, there's 50 of them, so there's not too many for them to have doctors or their med student friends look at and see if it makes sense. But when we run it through the AI, it gives us a very plausible and very actionable distribution about what's going wrong in Somalia. Half of the pregnancy-related deaths in the sample that they've done in their pilot were due to hemorrhage. So that means there's very specific ways to prevent hemorrhage that you might want to focus on if you're trying to bend that curve for maternal mortality in Somalia. Now they're going to go back and do a bigger study, and we'll see if things are different once they've got more data. But I am going to end on a positive, saying I think there's a lot of potential here for making a difference in terms of bending those curves by understanding cause of death, by collecting verbal autopsy interviews that we can now analyze with generative AI techniques. Thanks.
Wonderful. I think we have time for one question.
Just curious, I don't know the data, but like out of the maternal deaths you have in HMRC, what's the percentage that actually has narratives?
Most of them have they all ask the narrative.
Yeah.
But sometimes the narrative is like the respondent had nothing more to say.
Yeah.
The respondent was already crying, like stuff that is not useful information.
Yeah. I just feel like the conventional VA is not really emphasizing on the narrative part. But I wonder if there's any like difference or variation between different age groups, or maybe by sex, or maybe it's an interviewer sort of characteristic difference.
Yeah. No, I think that's a great area to inquire. And as you know, but not everyone might know, there's been a lot of, I would say, debate about how and when to ask for the open narrative. Some people who do these interviews say, like, just going in with the structured questions is really impersonal, and could we ask them how they're doing and what they remember first? And then other people have said, it's really helpful to kind of jog their memory with the structured questions and not lead them based on what they think has happened. So it's very valuable to keep it till the end. What these AI tools offer is like a chance to see in the data analysis side of things what difference it makes. Like we could try it with just the open narrative, with just the structured questions, with the combination, with the open narrative first, with the open narrative later. There's so many variations that I can imagine. And there's not a lot of guidance about how to check them out yet. So I'm pretty interested in kind of seeing that emerge. As Tyler said, they spent like $3,000 running different combinations. So in the maternal space, I had less. I only spent $20 so far, but I can see how that could easily get up to thousands.
Yeah, run some RCTs on how narratives is collected.
All right, let's thank AB one more time.